All right, this is 3.1 to 3.2 frequency distribution. Choose a classification. So step one, you need to make categories. They should not overlap and cover all possible values. It needs to make sure it gets every number in there, but it should never overlap. Also, qualitative categories are easy to identify. They're just, you categorize it by blue, red, green, etc. Quantitative categories can get messy with so many value ranges. Help with this. Count the number in each class. So step two, so after you choose what you're going to count by, count the number in each class, okay? So here's an example. A small commuter airline in the West keeps records of complaints received from its customers. Complaints are listed in the following table. Find the relative frequency for each category, then answer the question. So here are the type of complaints. Here's the frequency. Now, to find relative frequency, you are going to take how many complaints there are total and divide by how many times it actually happens. So how many times it actually happens divided by how many total points there were. Sorry, I had that flipped. Okay, so first of all, we need to figure out how many complaints were totally covered. So we're going to use some of our Excel information that we have learned. So we want all of them, so we're going to equal sum and add all these together, and you get 165, which actually, how many complaints were there? Right here it says 165. And then now we can use that to go ahead and find our relative frequency. So to find So what you are taking is you're taking the 26 divided by the 165, and that would be relative frequency if tickets cost too much. And then here, you're going to take that 11 divided by that 165, you get that 7%, and then you get the 29 divided by 165, 33 divided by 165, 6 divided by 165, and 26, you're going to do the same thing, so equals 26 divided by that 165, and then that 13 divided by 165. There is an easier way of doing this if you use your Excel commands, but I am writing, maybe. I am doing this way just to show you guys what relative frequency is and what you are doing. Okay. Okay, so those would be all the relative frequencies of this. You could have done the reference if you wanted to save some time, put that $sign in there and then drag it down. But now we can answer part B and C and D. What percentage of complaints were about the temperature of the plane? So if we go temperature. So too hot and too cold would be temperature. So together, so I'm going to add 16 plus that 8% right there. So 24% should have been approximately, okay? These are not exact. They did round the formula. Okay, would these categories be qualitative or quantitative? So if you look at the types of complaints, are they quantities or are they qualities? They are qualities, so this is going to be a qualitative. And it's also ordinal because order does matter, or order does not matter, okay? What is the level of measurement? That part is actually the ordinal part. So it's qualitative and ordinal for you. Okay. All right. Constructing frequency distributions. Determine how many classes should be in the distribution. More values, more classes. Between 4 and 20 is acceptable. Determine the class width. So to determine like the width of a frequency table, you're going to take the maximum number minus the minimum number of in the data, and then divide by number of class. Round any decimal results to integers to keep classes easy to comprehend. Okay. Find the class limits. Lower class limit, smallest number in a class, upper class limit, the largest number in the class, okay? Determine the frequency of each class. All right. So this is going to help you to just construct frequency tables like above. If it's qualitative, it's really easy because you can just go ahead and break it down into the things. But when it comes to numbers, it's a little bit harder. You're going to try to figure out how wide you want to count by. So do you want to count by fives? Do you want to count by tens? What? And that is where you find the class with the max minus minimum number of classes. Okay. A data set containing the heart rates of 50 students is below. Create a frequency distribution in the table below. Then find the relative frequency, cumulative frequency, and the cumulative frequency, relative frequency. All right, so let's go ahead and step through. So number of students. So instead of doing this for now, we could, to find the class width, I already gave you. So I decided that I was going to break it into 5 categories. So first step, I'm going to do equal. I need to find, if I look back up on number 2, I need to find the maximum number, my largest number, my minimum number, subtract those. So let's go ahead and do that. So max number, close parentheses, minus my mid number, my minimum. Oops. My minimum number. Right, and that would be here. Okay, so 36, and then I decided that I wanted 5 class widths, so I divided by 5, and so I needed to count by 7s, so or 8s. Okay, so 60 to 67, that's 8. 68 to 75, that's 7. 76 to 83, so that is where I got those class widths. Now, number of students within there, so you can use your count if you would like to do that. So count ifs. All right, so if we do this, we're going to do equal count ifs. Okay, since it's more than one, so we're going to select all the criteria, comma, and then we want this to be less than or equal to, because it can be equal to that bandwidth, 60, comma, and then we're going to select the criteria again. And then we also want it to be greater than or equal to, wait, it's greater than or equal to 60, and then we want it less than or equal to 67. Okay, there's 3 of those. All right, then we go 68 to 75, same thing, count ifs, select the criteria, comma, and then we want it greater than or equal to 68. Oops, finish it. And then select the criteria, or we would like it to be less than or equal to 75. Okay, now moving on, 76 to 83, so we want counts if. 76, so criteria. 76, so we want it greater than or equal to 76. Criteria again. Or we want it less than, oops, I need less than or equal to, 76, so it would be 83. Right, okay, and then 84 to 91 counts if. So criteria 84. Okay, comma, so we want it greater than or equal to 84, comma, oops, yep. And then, or less than or equal to 91. Oops. Okay, and lastly, which we should know this is 3 because there's 50 students, but equal to counts if criteria greater than or equal to 92. Criteria less than or less than or equal to 99. Okay, so to find the relative frequency, we need to know the sum of all those values. of all the how many people are taking it. We do know it's 50, but I'm going to just make sure it's 50 when I finish this, just to make sure I did the counts if right. All right, relative frequency. So then we take the number of students divided by the heart rate, which was 50. So I got 6%, and then I can come over here and just drag it down. Since that 50 was typed in, it won't change from cell to cell. It's just a number. Okay. All right. Cumulative frequency, the sum of the frequency of a class and all classes below it. Okay, so cumulative frequency, so this is going to be the same as the first one. So this is just going to be the same because it's the lowest width. Then you go to the next one, so this is going to be the number there was plus whatever the number before it. Okay, so 12. Then this will be that 25 plus that 12 before it. This is going to be that 10, that new 10, that new 10, plus the one before it, which is that 37. And then this one should be 50 if you added it correctly, because that would be the sum of all of them, because everything is below it, okay? Now, cumulative relative frequency, that is the sum of the relative frequencies and all the classes below it. So now we're talking about this column, and we're doing this, plus this, plus this, plus this, or you take this and you divide it by the sum again. So you're taking the cumulative frequency instead of just the relative the number of students previous by the how many there are. And this should keep going. So 37 divided by 50. And 47 divided by 50. And lastly, 50 divided by 50, which gives you 100% because all the numbers are below that. Awesome. Okay, so moving on. Now we're going to talk about some graphs and stuff like that. So bar charts. These are bar charts that you may see in your thing. They can be talking about things, people, places. Bar charts you probably have seen in your math classes previous. Okay. Then there's Pareto charts, bar graphs whose bars are arranged in decreasing order or frequency. Okay. So basically, here is the most frequent come here, and then it slowly goes. So bar charts, they don't have to, but Pareto charts, the bar graphs slowly decrease with time, okay? A stacked bar chart is a bar chart figure put together. So when they put two bar charts together, as you can see, the yellow is the gold, this is the silver, this is the brown, so the metals are put all together. Okay, so number one, according to the graph of the Winter Olympics, so that's this one, what country brought home the most medals overall? So if you're looking at it, the one that's the highest would be Russia. So your answer would be Russia. Okay, who score more silver medals, Norway or Canada? So we're looking at Norway right here, or Canada right next to each other, and you're looking at just the silver part. So Canada would be the winner there. Okay. Pie chart's a visual representation of the proportion between part to whole. So it's a whole is the everybody, and then the parts where it goes, okay? So how much money did the government spend on national defense according to the pie chart? So we're going national defense, which is gray, and so if you wanted over here, you could write how many percentage it is, but it would be 16%, and we want to know the total number, and they spent 3.36 trillion in total. So to find the part, oops, I should have put the 16% here. So to find the part of the whole, you're going to take that 3.36 trillion, which really is three. You can write it in scientific notation, or you can write it out 6, 1, and then 1, 2, 3, 1, 2, 3, 1, 2, 3. So that would be 3.36 trillion, and then times it by that 0.16. You change the percent to a decimal, and you end up with 5.376 times 10 to the 11. So 5.376 times 10 to the 11th. Okay, you can write it like that, or you can write it $5.376 billion. Okay, how much money did the government spend on Social Security according to the pie chart? Again, Social Security is blue, so it's 38%, and you're going to do the same exact thing. So if I did this, I'm going to write it 3.36 times 10 to the 12th, right? Okay, that equals that times my 0.38, and you should end up with, you can write it as 1.2768 billion, or trillion, sorry,